Alrighty, let's see what we got today. It's 1980. Find unique binary string. Previous Southwest. 1. Medium. Given an array of strings nums containing unique binary strings, each of length n, return a binary string of length n that does not appear in nums. Given an array of strings nums containing n unique binary strings of length n. If there are multiple answers, you may return any of them. 0, 1, 1, 0. So you can return 1, 1, 0, 0, 1, 0, 1, you can return 1, 1. Oh, okay. Interesting. So n is the length of this array, and there's 16. There's 16 things in n. Given an array num containing n unique binary strings of length n. What? So there's only 16 possible things. So it's length 1. N unique, so 16 strings of length 16 possibly. Okay. Nums at I is you. Yeah, okay. So, I mean, it's highly likely. It's highly likely that, I mean, I guess you just form a string. What do you do here? I mean, 16 is not very big, so you make a set of the strings in nums, and then create a string, and you can create up to 16 strings, like 0 to 16, and one of them should work. 0 to 16 inclusive. One of them should work as in one of them should not be in the array. Is that the best way though? What is the best way? What is the best way to do this? Why is this even medium? This should be easy if I think. If you can just brute force 16 possible entries. Think. How would n even work if n is 1? Okay, n is 1, it's either 0 or 1, right? Yeah, okay. I wonder if I can construct like a prefix tree. Maybe that's overkill. And it's called a prefix tree. It's called a trie tree. TRIE, try. Go 0, go 1. 0, 0, 0, 1. convert. I wonder if sorting it is too slow. I mean, it's only 16. I think sorting it's fine, and then like just identifying the missing one, maybe. So if I sort it, so if I sort like the example 3, 0, 0, 1, 0, 1, 1, 1, 1, 1, I could convert them to actual numbers. Convert them to actual numbers. And then remove the numbers from the set. Convert them to numbers. Iterate over all the numbers from 0 to 16. Find the number that's not in the set. Find the number that's not in the set. And then zero to 16. So 0, 0, 0 up to, let's say 0. So this is 2, 4, 8, 16. Yeah, so 0, 6, 0, 0, 0 to 1, 1, 1 is 16 values. Wonder if I can just no. Could be exactly 16. And a 2 to the 16th power is how much? 2 to the 10th is a million. No, 2 to the 10th is 1,000, so it's like, okay, 65,000. So it's not that much. We'll go ahead and just do, let's say, num set is equal to the set, and then for every value in the nums array, let's go numerical is going to be, I think it's something like binary of this string, bin of value. Converts the integer to its binary representation as a string. Okay, I want it the other way around. Value comma base. So I think I want to be the integer of this value base 2, and then numset appends that. Numset adds that. Sets add without order, rest appends with order. Do 1 2 0 1 1 3 7. Okay, so that's what I was hoping. So it would be something like for every I in range 17, because that should guarantee it. If I not in the num set, return convert this thing into binary. Return bin of I 2 onwards to ignore the 0b. Bin converts it to a string, but starts with 0b and then the actual bits in the string. And I want this to be zfill to the length of the nums, which is n. Zfill just puts leading zeros. And I think that's it. Kind of hacky. Alright, buddy. Alright. Didn't get to the 0 milliseconds. It's disappointing. Let me think. So I think the other way that I would approach this is because it's very finite. I think you're dealing with length 1, there's like 2 possibilities. Length 2, there's 3 possibilities. So you're dealing with 2 plus 3 plus 4, like total possible things that could work in terms of just guaranteeing an answer. 2 to 17, 2 plus 17, 19, 19 divide 19 times 19 times 19 times 9, so 200 something strings maybe. No, 19 times 9 is like 170, 171. So we're dealing with 171 strings. That can guarantee that all those strings would work. It's kind of a hacky solution, but I think this would work. So let's say for every length in range of 1 to 16, 17. So I'm going to do the pre-compute method. Every length in 1, so it would be something like for every I in range of length plus 1, I want to say. So if length is 1, it goes I in range 2, or it goes 0, 1. Yeah, so let's go pre-compute. This will be a 2D array. And this is the current is this list for this length. And then I'll do something like current dot append appends bin of I to onwards zfill to n, where n is the length. So zfills 2. Zfills to 1. And then after doing that, pre-compute dot appends the current. I'll just print out pre-compute. Too long. Oh, maybe it's not too long. Okay, so one of these strings guarantees to work. So I can just do something like, n is the length of nums, and then for every value in the array that is the pre-compute of n, so 1 goes to 0, so n minus 1. If value not in the nums, then return that value. I think this would work. Okay. Okay. I don't know if this was the best way. Feels like there was probably a more elegant solution. Okay, so what is the method I used here? The summary identified that given constraints of the problem, particularly that n equals is less than or equal to 16, that means that a 17th, but given 17 strings, kind of that at most 17 strings need ever be used to guarantee that one of them is not part of the nums array. So overall, generate strings of value 0 to 17 capped by the limit by the length n. And see if that string and see if and find the first of those. that are not in nums and return it. Can pre-compute the 17 strings based on the length involved. Stored in 2D array. We call this the precompute, where precompute of I equals list of possible strings where one of those is guaranteed to not be in nums. For example, precompute of, let's say, 1 is actually precompute of 2 is basically that, such that 2 values of length to array in nums, 2 values each of length 2 in nums will not have one of those in that list. Yep. So do your precompute. I is the index is the length very much, or length minus 1, and the value at the index is the array of binary strings filled into that length with possible values that exceed 1 more than n for the n. And then after that, I just find the value within the precompute list that doesn't match a value in nums. So time complexity is going to be O of 1, since you're basically doing 7 at most 17 kind of set checks to guarantee an answer. Space complexity is of 1, since you're storing a constant kind of space of pre-computed answers. So right, n was, I guess if n was more, then this thing gets bigger, right? Actually, I guess this is O of n. Yeah, guess store pre-computed answers, which can be up to n sized.